Okay, let's go for circuits part 2. We just did circuits part 1 in series and in parallel. The same thing right here, correct? Right here we have already set up the circuit, right, of 3 resistors like this one, correct? 3 resistors. Let's do first in series, right? So it's coming right in this way, taking only one path and goes to the battery. This is represented in this base right here, right? So we have the battery collected right here. It's gonna be only one path, right? The current, and it's gonna be in series then. Okay, this is also the batteries. This set of batteries are also in series, right? In series, these 3 batteries. Okay, now this is part A for this case. Part B is gonna be when the batteries are in parallel. And for these cases, let's look for the voltage, right? The terminal voltage, the equivalent resistance, the theoretical current, the experimental current. We have to measure it using these ammeters, right? In this case, let's use these ones, which are analogs, right? Ammeter and analog, right? Voltmeter. In part 1, remember we used this one, which is a digital one. Okay, now let's use these 2. These also are found a lot in the labs, right? Correct. And again, let's calculate the voltage and current using these devices. Perfect. Now let's go to part 1 in series, which is this circuit with the batteries in series. Okay, let's connect okay, this terminal to this set of resistors, right? The resistors are given right here, the magnitudes. As you can see, this is gonna be 5, 10 and 15 ohms. Great. Now let's close the circuit. Remember, a circuit means circle, so we're creating a circle in this case. Okay, now is set up this circuit. Okay, great. Now let's involve the meters. Let's see what is the voltage, right? The terminal voltage. Let's find it. Okay, let me connect these to the batteries. As you can see, it's close to 5, right? Very close to 5. Okay, like a 4.5. Great. Later you can please magnify, right, or zoom in, right, this figure, right, to see more accurately what is happening. Okay, great. So we already measure, right, the voltage, the terminal voltage. Now let's go for the experimental current. Okay, the theoretical current, remember, you're supposed to find it once we know the voltage and the equivalent resistance. The equivalent resistance, remember, you have to use the rule for resistors in series. Correct? Actually, the resistance is the equivalent is just the sum of all of them, right? And then you plug the values right here to find the theoretical, right, current. Now let's find the experimental. What is the current through this circuit? To do that, remember, we have to break the circuit. This is right, it's coming right here. Let's break the circuit, open it. Let's place inside, right, the ammeter, which is this one. So it's coming in this way, correct? It's coming. So now it's connected to this is the other. Let me do it this way in the video. Okay, this is the other end. Now let's go to connect it to the ammeter, the analog ammeter, to find the current, right? Okay, I did it by myself. Okay, now you can see the current is represented in that way. That again is the experimental, right, current. Later I'm gonna show you how to use the scales. Okay, perfect. This is a case for batteries in series. Now let's go for the case when the batteries are in parallel. Okay, let's do it. So let's rearrange again. Let's remove this, right? These are movable, these batteries. Now let's place them in parallel, correct, in this way. Let me see how they go in parallel. Okay, let me see. Okay, they go in this way. Okay, in this way. This is one, right? This is the other one, like this. Perfect. I did it by myself. Okay, now these are batteries in parallel, correct? Now the same thing. Let's try to find the voltage, right, terminal. But before that, let's connect this to the circuit, the set of resistors which are in series. Okay, let me see if this is correct or not. Yes, this is one, and the other one is let me move this one right here, right? Okay, am I doing it right? Wait a minute, it's in parallel. Was right, I was right before, correct? This is one. All of these are negative and all of these positive. We're in parallel, positive with positive and negative with negative, correct? Perfect. Okay, almost done. Great. Let's complete the circuit. Okay, that's the circuit for batteries in parallel and the resistors are in series, like this. Okay, now let's find the voltage. Okay, let's do it. The voltage, the terminal voltage. Okay, let's plug this right here, right here, and this right here, and look for the voltage. Look, as it goes negative. Let's switch this to. Okay, oh my god, let's hopefully you can see it, right? Okay, okay, let's see. Okay, can you see it? Can you see the voltage? Okay, that's the voltage in parallel. Wow, but look the scale. We're in the scale of 15. Okay, the scale of 15. Let's go to the scale of 5, right? The first one was, the scale was right here, right? 5, 15. So let's go to a scale of 3. Let's see what happened in the scale of 3. Okay, let's do it. Now let's use this scale, the bottom one. Okay, and repeat. Okay, to find the voltage. Great. One more time. Oops. Again, we have to reverse this too. Okay, let me do it this way. Okay, let me see. Okay, what happens? Oh my god. Okay, see, now that's gonna be the voltage. I can't believe it. Okay, great. That's the terminal voltage for these batteries in parallel and resistors in series. Okay, now let's find the current. Remember, according to this experiment, we are looking again for voltage. We just found it, right? Now let's find the theoretical. Well, the same thing as before, voltage divided by the equivalent resistance, right, which is the same as case or part A. Now let's go to the experimental value. Okay, for the current, the same thing as before. Okay, let's break the system. Let's remove this connection from here. Let's introduce the ammeter right here, and go back to the circuit, right? I remember the current, it must be in series with the circuit, correct? Can you see it? Okay, look, what is the current right here? Well, it's kind of small. Let's go to a scale 3, right? The scale of, no, actually, look, the scale is 0.6. Okay, I was looking at the as this one, right? This scale is 3. Now this one scale is 0.6. See, for this scale 0.6, this is gonna be the current. It's very small. I'm gonna show you later how to find that current. Can you see it? Okay, we are dealing with, look, it says 0.6 right here, right? The next one is at 3 amps, right? 3 amps and 0.6. I'm in 0.6. So these two give us 0.6, and these two are 3 amps. Okay, can you see it? Okay, perfect. Now let's go to the circuit in series, in parallel, sorry, in parallel right here. Look, wait a minute, right here. Let me move this part. Okay, now let's go to this part, right? In parallel, it's gonna be the same set of resistors, right? They're right here. Let's remove the cables right here, and now let's make these 3 system of resistors in parallel, right? In parallel means that these 3 are connected, like in the figure, right? These 3 are connected, these 3 are connected, and goes to the battery. Okay, let's do it. So we have this one connect right to the next one right here, and the next one, and the next one, yeah, the next one to this one right here. I just did it. Okay, this is these are connected in parallel. The same thing for the other side, right? We have we can use the same colors also to match the let's say positive and negative, correct? Okay, so these one are coming, and it's gonna be in parallel. Okay, great. Now these are in parallel, these 3 resistors, right? These 3 are joined together, this together, and this together. Now this go to the set of batteries. Now these are already right in parallel too. So mean that let's do it first, right? Part B, because the batteries are already for that part. Okay, let's use them. So that's the case when we have batteries in parallel and the resistors are also in parallel, right? In parallel. Okay, let's do it. Perfect. As before, right? Let's connect this to the I'm looking for more wires. Okay, it's coming. Connect this to the battery, correct? So it's coming right here. Oops. Okay, to the battery. Because these are so small, I have to make the camera very close to the devices, right? Okay, this is one part. We have another one. Okay, and they go to the battery. Perfect, we just did it. I can't believe it. Okay, almost done. It's coming. Okay, what's happening? Okay, I just did it. Okay, now the circuit is ready. Great, see, that's the circuit. The series are in parallel and the batteries are also in parallel. Okay, now let's find again the voltage. Let's find the voltage for this one. Okay, so the voltage right here. Let me place it right here. Correct. Now you can see in this way. Let's connect the terminal. This is one right here, right, and the other one is coming. Okay, right here. See, but the scale is 3 volts. See, this is 3 and this is 15. We are in 3 volts. Okay, for that scale, look, this is the voltage. Okay, for a scale of 3 volts. which is what, about what, 1.5, right? Something like that. Okay, perfect. Great. Now let's go to find the current. To do that, remember, we break the circuit. Let's break it from here. Let's break it. Right, it's broken. Now let's place in between the ammeter, right, in between the batteries in the circuit. So it's coming. Okay, it's coming. Let's use point, let's see, 0.5. Hopefully gonna be enough. 0.5, right, amps, the scale. And again, now let's go back to the circuit. Maybe you can see. Okay, let's go back to the circuit. What happened? When it goes opposite direction, means that we need to switch, right, that direction right here of the current. Okay, let's do it. Now let's use a 3 amps. Okay, 3 amps. Let's switch it to 3 amps to see it works. Okay, it says 3 amps. Look, this is 3 amps. In the scale of 3 amps we have right there. Now let's switch it better to 0.6. Okay, one more time, 0.6 amps. Okay, let's see. It's better, right? It's better. We can see it. Okay, let me connect it. Okay, so this is, again, one more time, look, this is for 0.6. so this is gonna be again the current. Okay, close to 0.4. Okay, perfect. Great. Again, this is the experimental current for the circuit, the resistors in parallel and the battery also in parallel. Now let's go to resistors in parallel and the batteries in series. Okay, let's do it. Let's do it. Let's remove the ammeter right from here. Okay, and from here too. Perfect. Let's put back this wire right here. Okay, almost done. Can't believe it. Okay, it's done. Perfect. Now let's take the batteries in series as before. Okay, it's right here. Let's remove this one. Okay, 1. Okay, and 2. And now these are going which way? Okay, let's move this way right here. In this way, this is, oh no, it's coming. How's coming this one? In this way. In this way. Oh, let me see. I just did it. Okay, it goes in this way. I just did it. I can't believe it. I forgot already. What? I forgot? That's not good. Okay, I found. Okay, I found it. Okay, I can't believe it. It's right here. Okay, this is 1. Okay, and this is the second one right here. Okay, I just did it. I can't believe it. It was like this. Oops, sorry. Okay, it's coming. I want you to see. Okay, great. I did it by myself. Okay, and now the batteries are in series too. Now this is again for part A right here. Batteries in series and the resistors in parallel. Okay, resistors are in parallel, right, and the batteries are in series. Okay, great. Let's do it. Let's connect them again as before, right? So one of these terminal goes to the circuit right here. Okay, perfect. Right, and the other one goes to the other end right here, right, the other terminal to the other end of the set of resistors, right? Okay, perfect, like this. Okay, and it's ready. Perfect. Now let's find the voltage when the batteries are in series. Okay, look, it's gonna be the voltage. Let's use 15, scale of 15. Okay, let's remove the wire from here and go to 15 scale. Okay, great. Okay, now let's go to the terminals is 1, and this is the one right here, right? Okay, this is the scale of 15. Let me fix this to show you better what is happening, right? To get closer the voltmeter, okay, for you to see it, because these devices are very small. Okay, it's right here. Look, can you see it? Okay, this is in the scale of, look, 15. So it's the top one. Okay, perfect. Now let me remove the voltmeter, right? But the circuit must be coming back, putting back again. Okay, and we are going back to the original one. Again, this is series, series and parallel circuit. Okay, now let's go to find the current right here in between. Okay, remember we break the system and we put it back to the okay, what is it right here? Can you see it? Okay, let me move a little bit in this direction. Okay, now we break the system again, but not being serious, or to go back to the set of resistors. Now let's use the current. Okay, it looks like we need to switch the direction of the current. Look, that's gonna be we're in the scale of 3 amps. Okay, we're in the scale of 3 amps, correct? So, and you can see in the scale of 3 amps, this is the current. Again, we are dealing with 3 amps scale right here, correct? So this is gonna be it's about one amp, right? Perfect. And this is the experimental current. Okay, now you're supposed to find the theoretical current right from the theory, correct? So this is the theoretical one from the current. It's gonna be voltage. I just mentioned, we just found it, divided by the equivalent resistance. The experimental is given by the ammeter all the time in this experiment, correct? And the same thing for the varies in parallel. Got it? Okay, this is the way how we are supposed to read the scales, if you are not familiar with it yet. Okay, for the ammeter, right, we use these two scales from 0 to 3 amps and from 0 to 0.6 amps, correct? When we use a 0.6 amps scale, right, each line counts, right, 0.2 amps divided by 10 equals to 0.02 amps for each, right, small right line, correct? When we use the 3 amps scale, right, because from here to here, from 0 to 1 we have 10 lines, right? Each line counts 1 over 10, which is 0.1 amp, correct? Now we move to the voltmeter the same way, right? We have 2 scales. We have a different ones where we have up to 3 or 4 scales. Okay, the same thing for the 3 volts scale, right? When we connect these two is 3 and this 2 is 15. Okay, right here for the 3, right? Because from 0 to 1 we have 10, so we divide 1 by 10 is equals to 0.1 volts. For 15, right, from 0 to 5 we have 10 lines, right, so we divide 5 volts over 10 equals to 0.5 volts, right? This is the way how we read again these analog meters. Okay, and with this we finish this experiment for you. In this experiment we need just to calculate, correct, the theoretical values for current, right, for these 2 cases. Find the percent error for each case. So we have 4 resistors in series, and 2 4 resistors in parallel, so total 4% error. Okay, great. So see you in the next video. Okay, bye. Okay, perfect, beautiful.